Okay. I've been working on optimizing now. So I used to, get a whole bunch of data, set the span, set the center, get the data, set the frequency, set the data. Okay. But, and then here, a whole bunch of different things: start, stop, start, stop, start, stop, start, stop, get the data. So I created a couple actions to obfuscate that based on the model of the device. Okay, so if it's this model, do this command. If it's so here, let's sort by model. So if it's a CN, behave like this. If it's a 40B, behave like this. And I created a couple action categories. Okay, so set, that says, okay, well, it's one simple thing and a variable. Then I have rig. So I created rig. So it's one, two variables. 1, 2, 1, 2, 3, 4. So rigging is setting multiple settings all at once. Then I have nab. So nab is get multiple data points all at the same time. So here, frequency start, frequency stop, trace data. So what's the start, what's the stop, give me the data. What's the start, what's the stop, give me the data. Then I created one called get. So get is just, questions. Get the starting point, get the starting point. Do is simply do this, okay? Initiate consistent. Do this reference level. Become this reference level. And then I created beg. Okay, so beg is a new idea. It kind of combines two things. So it begs to ask a question. Okay, so it says tune here. So tune to 111, 222, and then give me the trace data. Tune data. Set the frequency span, set the center, give me the data for the span and center. So it combines asking and setting in one command. So of course I had to create an experiment to validate this. So this yaks to those commands, right? So the interpreter, the program shouldn't talk to the device directly. So the experiment talks to a handler that then talks to the yak that then talks to the equipment. So here I set the start, I set the stop, and in one command I get frequency start, frequency stop, question, answer. And then here I get span. So here I set the center and then I set the span. So I get tell, ask, answer. Okay, and then here markers. So I created a demo 111, 222, 333, 444, 555, 666. So I go marker place all. The analyzer places them, and within two commands, so it goes turn on all of the markers. I don't care if you shut them off, just turn them on. And it's a long one. So it asks the question. So it turns them on, sets them to a frequency, right? So it sets the frequency, and then it just keeps going. The command is like a concatenated one big huge command. And then it returns the values 1, 2, 3, 4, 5, 6. So I get 6 values back. Same thing with the trace types, right? So I set all 4 trace types in one shot, and then I get a result back. So it goes yak, beg, and now all 4 traces behave like they're programmed. And then trace data. Okay, so if I choose, trace number 1, I go yak beg, and what it's doing here is in 2 lines, I say, okay, tune here, tune to this stop frequency, and then give me the data. And then it gives me the data. And because I know the yak beg knows the start frequency and the stop frequency, it looks at all the CSVs that are associated with it, it counts them, and then it divides it by the values. So if it starts at 1,000 and it starts at 500 and ends at 1,000, it divides these equally into different things. So the markers and the presets and the scanning and the plotting, they don't actually talk to the device. They talk to a handler. So I call it so there's a couple handlers. A handler, and then that talks to the yak, and then that talks to the yak visa. So the program actually doesn't even, the program doesn't talk to the device. The yak talks to the device. The yakety yak, I called it actually. The yakety yak. Do talk back.